Hello everyone. My name is Siddhant Kannan. I'm studying in Sri Venkateshwara College of Engineering, third semester CSE department, USN 1V22 CS 151. And today we're going to be talking about the allocation of frames and thrashing, which comes under the subject operating systems. So, what is allocation of frame? Consider a single user system with 128 kilobytes of memory composed of pages of 1 kilobyte in size. This system has 128 frames. The operating system may take 35 kilobytes, leaving 93 frames for the user process. Under pure demand paging, all 93 frames would initially be put on the free frame list. When a user process started execution, it would generate a sequence of page faults. The first 93 page faults would all get free frames from the free frame list. When the free frame list was exhausted, a page replacement algorithm would be used to select one of the 93 in memory pages to be replaced with the 94th, and so on. When the process terminated, the 93 frames would once again be placed on the free frame list. There are many variations on this simple strategy. When this space is not used by the operating system, it can be used to support user paging. We can try to keep three free frames reserved on the free frame list at all times. Thus, when a page fault occurs, there is a free frame available to page into. While the page swap is taking place, a replacement can be selected, which is then written to the disk as the user process continues to execute. Other variants are also possible. The user process is allocated any free frame. Here are some algorithms for allocation of frames. The two most commonly used algorithms to allocate frames to a process are equal allocation of frame, in which each process gets equal number of frames, or proportional allocation of frame, in which frames are allocated to each process according to the process size. Here are some of the constraints of allocation of frames. You cannot allocate more than the total number of available frames. At least a minimum number of frames should be allocated to each process. As less number of frames are allocated, there is an increase in the page fault ratio, decreasing the performance of the execution of the process. Number of allocation of frames is defined by instruction set architecture. Now we are going to start talking about thrashing. So, thrashing is essentially swapping out a piece of a process just before that piece is needed. The processor spends most of its time swapping pieces rather than executing the user's instructions. This activity is known as thrashing. If A does not have enough pages, the page fault rate is very high. This leads to low CPU utilization. OS thinks that it needs to increase the degree of multi-programming. Another process added to the Here is a basic graph which displays the relation between the CPU utilization and the degree of multiprogramming. Here are some of the disadvantages of thrashing. It increases the degree of multiprogramming, system output decreases, page fault rate increases, and effective access time also increases. In order to reduce the effect of thrashing, we can do the following: using local replacement algorithms provides as many frames as it needs, increasing the size of memory as well as decreasing the number of processes running. Thank you for watching. We have now come to the end of this video. Please like, comment, and subscribe, and I will see you in the next video.